I'm going to do a second example of completing the square, and this time it's not going to be such a nice one because that pink value is not going to be broken quite as easily as the one we did in class. We definitely know that we want to have some kind of square because we're going to try to write this with a binomial squared. So we know that it's going to be same side, something like this. And we definitely have the idea that this green area is represented by the x squared, and these pink areas are represented by the 5x. And we want to guarantee that this is a square, so we want these pink rectangles to be the same thing. And then that 3 is kind of like floating out. We deal with him later on. We're going to have to make a square. We don't know what that square looks like. We'll have to complete that square at some point. And the part that everyone's pretty comfortable with, I'm sure, is that green part being x squared means we have to have x and x. And to make these pink parts the same, we want to split this directly in half. Now, you have a couple choices. One choice is to do this. That's what you're all going to want to do. And I'm going to caution, like, don't do that. And here's why. When you get used to working with fractions and you decide not to be a big baby about them, no offense. I'm not trying to offend you. I'm just saying I was the same way. When you get used to fractions, they're actually way easier to work with in a math class. So another way to take half of -5 is just to think of it as -5 divided by 2 and then don't actually do the division. So if I take this and split it in half, here's how I'm going to write it. Here's how I'm going to write it. And just in case you're now something like, oh my gosh, fractions, Mr. Dipstick, I'm scared. Let's keep in mind that these areas of these rectangles are still base times height. So this is a -5/2 x. This is also a -5/2 x. And if you add a half of a 5 and a half of a 5, because that's what that says, you just get a -5. So we're not going to stress out about it. We're just going to take this value, we're going to cut it in half. And the reason why we math nerds, like fractions better is because we have to complete this square. Like this blue area down here, it's not at all related to the 3 from before. That 3, like we're not factoring this time. We're trying to make a square. These pink values have to be -5/2. That forces what this blue value has to be. This blue value has to be this times this. And for me, if I had to take a -5/2, if I have a choice between taking -2.5 like you guys want to do and multiplying it by another -2.5, I don't want to do that. If I can take a -5/2 and square that, all I really have to do is square the top and square the bottom. And I definitely know that this squared is 25. And I definitely know that this squared is 4. That's good enough for me. Perfect. Great. I love it. Let's put that in blue, though. It's always cool when a little gnat flies by your head when you're doing math. So square the numerator, square the denominator. We're all good. But because we had to add that into the problem to complete the square, I don't want to really change anything, so I'm going to subtract it out again right away. And yeah, it looks a little horrifying, but I'm going to stay calm. This whole piece right here is this entire square, and its area can be represented with the expression side squared. So that's x minus 5/2 squared. And then this portion is whatever I get when I combine -25/4 and 3. Feel free to use the calculator here if you want to. If you want to be ready for the SAT in that non-calculator portion, you might be like 3 to combine fractions. I've got to have common denominators. That's really 3/1. I need for these to match. So if I make that 4 times bigger and I make that 4 times bigger, I end up with something more like this. And now that the denominators are the same, that makes -13. And like I said, you are welcome to use a calculator to figure out this what you get when you combine these. I don't have a problem with it. But if you want to practice fractions, this is a great chance to do it. So that's it. That's the answer. And if I just wanted to really verify it, of course, what am I going to do? I'm going to crack open Desmos. I'm going to graph this version of it. I'm going to graph this version of it and see if it works. So x squared minus 5x plus 3. Whoops. So we have x squared minus 5x plus 3 was the standard form. And I think my form with the binomial squared is x minus 5/2 squared. Whoa. Come on, decimals. Let's not go crazy. Minus 13/4. Oh, it's such a great feeling when you risk working with fractions and you do all this stuff that you haven't thought about since probably 4th grade, and you see these answers and you get a little butterfly in your stomach because you're not sure if you're right, and then you throw it in decimals and it worked out perfectly even though it looks weird. It's like you feel like a boss, as the kids say. So that's my tougher example. Just the main steps are the same. That pink value gets cut in half. The blue area gets forced upon us based off what half the pink areas were. So we have to add and subtract that number. We express that area as a binomial squared. And whatever's left outside just gets combined to keep things nice and equal. That's how we're going to do it. Good luck.